Measurement, units, and significant figures. Here are your priming questions. I place these three together because they work together to help you understand the importance of measurements with their units and also the amount of error within those units through the use of significant figures. This is easiest to talk about when we talk about length and measurements using meter sticks or rulers. Here are the base units that we're going to be working with meters, kilograms. When we talk about temperature, we'll be in Kelvin or converted to Celsius. And with time, that's going to be in seconds. We're not going to worry too much about moles. We will be talking about amps for current in term 2, though. Now, so we have measurement, our units, and our significant figures. So the first thing that I want to mention is with any measurement that you make, it's going to have a value and a unit. You need to make sure to give me units with any of these measurements. Otherwise, you will have points taken off, and I won't know what you're trying to tell me or what you're trying to represent, whether it's in a lab or a quiz or on a test. So you need to make sure that you have your number with its unit, or I should say appropriate unit. Okay. Now, if we look at the measurement here, let's say we're trying to measure the length of this particular line. We want to have as good of a measurement as possible, which means we want to have the greatest number of significant digits so that we have the greatest confidence in our measurement. When you first look at this particular line, and with this ruler that's given to you, and let's say that these are centimeters across the top here, at first you might just say, well, that's about 2.5 centimeters. And the first thing I want to mention is we will be using decimals in this case. We will rarely, if at all, use fractions. So never put 2 and 1/2. So you'll do 2.5 in this particular case. But if you look more carefully, what you'll notice is that it's actually a little bit less than 2.5. And so if we want to be as careful with this measurement as possible, we know it's going to be 2. It's going to be our units digit. And then the next one is going to be a little bit less than 2.5. So it's going to be 2.4. And now what we need to worry about is this last digit. We need to estimate this last digit. If possible, not all measurements will allow us to be able to do this. In this case, we look at the markings and we can estimate this next digit, and it looks to be about 8/10 of the way there. So I'm going to say 2.48. And again, we're working with length. We're not measuring this in meters. This will be in centimeters. So we need to make sure that we put centimeters. And so this would be the best measurement that we could have for this particular length of this line. When we are using our meter sticks, if you are less than 10 centimeters that you're measuring, you should be able to get 3 significant digits, and we'll talk about that in just a moment. If you're measuring greater than 10 centimeters, you should be able to get 4 significant digits. So keep that in mind for any of our labs where you need to make measurements using a ruler or one of the meter sticks. And make sure to keep in mind our base units, as well as whatever units you're using to measure with. Significant figures. Significant figures, the main idea for this is to give you an idea of the amount of error in your measurement and in your calculation. So it tells you how confident you are in that particular number and its value. So here are the rules. You can read through those, you can pause it. I'm going to go and move on to these practices. The ones the one that produces the most confusion is going to be this one. And I want to quickly talk about number 4. There are going to be values that have zeros in them, and in some cases the zeros are going to be significant, as in number 2 and number 3. But in some cases, if those zeros are just placeholders, those zeros are not significant. And I'm going to show you B for that. So if we look down here for practice B, we have 0.0004987. So we know that all digits that are not zeros are significant. So we know the 4, the 9, the 8, and the 7 are significant. But now we need to figure out whether the 0, 0, 0, and 0 are significant or not. And so when we look at these rules, these zeros are not at the end of a number. So we can't use rule number 2 to say that these are significant. And these zeros are not appearing between. And when you look at this, these zeros are actually just placeholders that tell you how far away the other significant figures are from the decimal place. And so these are just placeholders, and if you think back to your scientific notation, you wouldn't even see these in the scientific notation. It would be 4.987 times 10 to the negative 1, 2, 3, 4. And so in this case, only the 4, the 9, the 8, and the 7 are significant, so we only have 4 significant figures here. If we look at practice A, 134.2 grams, these are all non-zero digits, so all 4 of those are significant. I also want to quickly mention number 5, the rule, and these numbers, so this is if we're counting or if we have what we call exact numbers, so that's what we're going to be using for defined constants. And all that really means for number 5 is that when we have these values, we don't take their values into account for our significant figures. So let's look at practice C. We have 104 milligrams. We know the 1 and the 4 are significant. Now we need to figure out whether the 0 is significant or not. We look at rule number 3. Zeros appearing between significant digits are significant. So we know that that 0 is significant. So we have 3 significant figures. If we look at practice D, 45.00 milliliters, we know the 4 and the 5 are significant. Now we need to figure out whether these two zeros, one or both, are significant or not. These zeros are at the end of a number and to the right of the decimal, so these two zeros are significant. So we have 4 significant figures. So I want you to do E, F, G, H, and I on your own. We'll check them in class. As a quick note, engineering notation is acceptable for me. And by this I mean, if we look at 400 meters versus 400 point meters, just using the decimal there, these might seem to be the same at first, but they are actually very different with their measurements. So for example, if we look at 400 meters, and when we think about the number of significant figures, these two zeros are not significant. So in this case, we only have one significant figure for this measurement. Whereas when we look at the 400 and then the decimal meters, what this decimal means is that the zeros preceding it, these two zeros, are significant. So we have 3 significant figures here. When we're working with our significant figures, this tells you how much error you have, which means how much that number could have been rounded. So if we have only this first digit being significant here, 400, what this means is the actual range for that measurement could have been anywhere from 350 meters all the way to 444 really meters. Because if we were to round these to just one significant figure, this 5 would round the 3 over here up to a 4, so it'd be 400, and then the 4, these 4s would round, or this 4 would round down, which would also be 400. So only having one significant figure, you can have a lot of error there, and you are not very confident in that measurement. Whereas with the 400 dot, you have 3 significant figures. The greatest range that you could have with this is a much smaller range. Rules. Now, for calculations, for me, what I want you to do is, when you're working out your calculations, I want you to do all your calculations using all decimal places, which means do not round throughout the problem, round at the very end. Okay? So you look at your original numbers used for the calculation once you have your answer, and then you want to rewrite your final answer using the same number of significant figures as the original value with the least number of significant digits. From there, you round as needed, and you don't consider constants or counting values when we're talking about these significant figures. So let's do a quick example. Let's say we want to find the area of this rectangle. And so we again have our measuring device, and we are measuring lengths less than 10 centimeters, so we should be able to get 3 significant figures for both of our measurements. And so when we look at this, we can see that this is a little bit less than 5.2 centimeters, so we know it's going to be 5.1 something. And when we estimate this, we can say this one looks to be about 5.17 centimeters to me. And now, So we have our 3 significant digits. Now we move our ruler, and we look at this side, and now we see that that's close to about it's a little over 1.9, so we know this will be 1.9. And now we estimate the next digit, and let's say that is right around 1.95 centimeters. And now if we want to find the area, we would simply have to multiply these two together, the width times the length. So we have 5.17 times 1.95. And let me use the calculator now. I can't do this in my head. So 5.17 times 1.95. And my calculator gives me 10.0815. And this would be centimeters squared. There you go. Now, this is not going to be the correct answer that I would accept, though. Here, if it's written out this way, if we count our significant digits, we have 1, 2, 3, 4, 5, 6. Whereas if we look at our original measurements only have 3, which means that we need to rewrite this answer and round so that we have 3 significant digits, which means that these 3 places must be significant and that we need to round this to this one. Okay, so we would write 10 point, and the 8 would round the 0 up to a 1. And so this would be 10.1 centimeters squared. And here are your primary questions again.